Simultaneous equations. Again, everybody please listen. Simultaneous equations are giveaway marks. They are, most of the time, 3 marks or 4 marks. They literally are giveaway marks because I've only told you, I've only recommended you one way to do it in AMATS. I recommend, And what is the method? Substitution. Looking at equation number, the 2 equations given to you, what do you want to substitute into what? Obviously, the first one is easier to make either x or y the subject. And you substitute it into the second equation provided. Okay? So, everybody is able to do substitution. You're all able to make something the subject. So, this is not a problem. The problem comes when you do substitution. You make careless mistakes. Okay? So, what do I mean by that? Okay, if we were to substitute equation number 1 into equation number 2, we do it properly, this is what we get. 2y squared minus this entire thing was our x value with brackets. And over here, I do the substitution with brackets again so that I do not make any careless mistakes. From here on, expansion is not a problem. But some students chose not to put in the brackets. They ended up with this. 2y squared. Let me zoom out. They ended up with 2y squared minus, this is their value of x. Okay, no problem so far. Then they have a y over here plus blah blah blah. Now the next step, we all know that we want to get rid of the denominator, so we want to multiply by 2. Okay, so when students chose to multiply by 2 this way, they forgot that this sign is going to be multiplied with this negative. So without the bracket, some students simply wrote it as 4y squared minus 3y squared. Okay, this one is still okay. Now the next one, they think it is simply negative 1 times y, and they leave it as negative y. Instead of this negative sign multiplied to negative 1, you should end up with positive y. So is this a mistake that could have been avoided?
Yes.
Absolutely. How do we avoid it? You put in brackets over here, you will not make the mistake. So this is the basics from your Sec 2 work or even Sec 1 work. So from here on, expansion, simplification, you get a quadratic equation. Once you get a quadratic equation, you can use either your quadratic formula or factorization or completing a square if you like to solve for 2 answers for x. Once you have your 2 values of x, substitute them. Sorry, you have your 2 values of y. Substitute them to get your corresponding value of x. This is how your answer can be presented. Or you can say when x equals to negative 25 over 2, y equals to negative 8. When x equals to 1, y equals to 1. 2 ways of doing it. Right, so where are the marks allocated? So this is a 4-mark question. Our marks are allocated over here. 1 for the correct substitution. You can make y the subject, make x the subject, up to you. As long as you do the substitution correctly, you get 1 mark. Next, expansion. Expansion and simplification into a quadratic form. You get another mark. Final pair of coordinates, final pairs of coordinates, you get the other 2 marks. Questions? So is this an easy 4 marks? Yes, it is. No reason that you cannot do it. Now, question 2. Find the values of A, B, C. Look at the number of steps required for 3 marks. Look. what have you done in your own work? Left hand side is always equal to right hand side. You want to find the values of A, B, and C. You get to choose whether you want to expand everything out. Can you imagine a pain where you expand this? How painful is it to expand and get every single bit correct? Yeah, some of you managed to expand it correctly. Fine. Then you just compare coefficients. You will get a correct answer. The moment you make a careless mistake, it's gone. So what is the best way to do it? Observation. How do we get, for example, x cubed terms? X cubed terms are obtained by 2x multiplied by x multiplied by ax. So these three give us 2ax cubed. There is no other way you can get x cubed term. So we compare this with 4x cubed. That means a must be 2. And that's 1 mark. Then, in order to find something else, for example, the constant term, 6, on the right hand side, how do we obtain a constant term? You have so many things to multiply. The only way to get a constant term is to take -1 multiplied by +2 multiplied by b. So this 3 give me -2b must be equals to 6. b must be equals to -3. That's another 1 mark. Now finally, we want to find the value of c. You can do the same thing. Okay, how do I get an x term? X term will be 2x multiplied by 2 multiplied by b, which I found out. It can also be -1 multiplied by x multiplied by b. And we've got one more. Do we have one more? We've got one more. -1 with +2 and ax. This gives me 3 x terms. Then I combine them, I compare it with our cx. That is one way to do it. But that's not the easiest way. The easiest way is to, since this is an identity, left hand side always equal to right hand side, no matter what value of x you put in, just choose a value of x to substitute in. No matter what x is, left hand side will always be equal to right hand side. So in this case, the teacher chose x equals to 1. Substitute it in. 4 plus c plus 6 equals to blah blah blah. So c is -13. How easy, how straightforward, isn't it? Is this something that you haven't learned before? No, right? So the first page, how many marks already? 7 marks. 7 marks almost for free. Okay? Second page. Now, they say that fx equals to 2x cubed ax squared plus bx minus 9. We see that there is an unknown over here, b and a. And they tell you that fx has a factor of x minus 3. Factor of x minus 3. This tells me that f of 3 equals to 0. Since it is a factor, the remainder is 0. Then it has a remainder of 8 when it's divided by x plus 1. This tells me that f of -1 equals to 8. Are you able to see these two? Okay, if you're able to see these two, then it's again quite straightforward, isn't it? Let's start with the first one. F of 3 equals to 0. I see that many of you managed to write down f of 3. Then you do the substitution. Very happy. Substitute and you get, this is what you do. 27 times 2 is 54 minus 9, 45, plus 9a plus 3b. This is your f of 3, right? Then you continue. No, once you reach this step, you don't know what to do. You only know I must substitute 3 inside all the x. And then you get 9a plus 3b plus 45. So what's that? What's that supposed to be? It is supposed to be equal to 0. Did you write that down? If you didn't write that down, you cannot solve. You don't have an equation. If you don't write it is equal to 0, all you have is an expression, which does not help you solve for a and b. So over here, once you manage to make the equation, from the equation you get 1 mark. Or any other equivalent, 3a plus b equals to negative 15. Any equivalent equation, I give you 1 mark. Next, f of negative 1 equals to 8. Okay, so again, you are very happily doing your substitution. You see that f of negative 1 equals to this, and you don't write down it is equal to 8. Then how are you going to solve it? You only have an expression. So after this, you need to write down, okay, since this is the remainder, and the remainder is negative 8. Sorry, 8. So you must put down it is equal to 8. How many of you did not put down it is equal to 8? Then you were lost. You're not sure what to do. Then you simply pretend that this is equal to 0. And then write a minus b equal to 19. A minus b equals to 11. How can you do that? You cannot be guessing. You cannot be pretending that an equation exists where you are not forming the equation. Once you form the second equation, you get another 1 mark. These are two simple simultaneous equations that Sec 2 you have learned at the start of the year. A equals 1, b equals negative 18, 1 mark each. Look at the working. It's not complicated. So generally okay for this question. Now, hence, solve. When you see the word hence, you must use what was found in the previous part. You are not allowed to do it any other method. You must use what you found in the earlier part. So, 2x cubed plus ax squared plus bx minus 9 equals to 0. Okay, what we found out earlier on was that this is an expression. This is a function. Is it an equation? No, it is not an equation. I didn't say it is equal to a certain value. But I do know that it has a factor of x minus 3. This expression over here, is it linear? Is it linear? No. No, is it quadratic? No. Is it cubic? Yes, sir. Yes, it is cubic, right? Look, they are asking you to solve a cubic equation. How many ways of solving cubic equations do you know? 3. What are the two?
Long division and the other one is
Okay, regardless whether it is long division or you substitute in values, we require the very first factor, isn't it? Yeah. We need one factor first. That is the only approach for solving cubic equations in our syllabus. So do you want to do try and error to find the first factor? Yeah, we already have the factor given to us. X minus 3 is a factor. Since x minus 3 is a factor, I can do long division. This is my fx. I divide by x minus 3. Of course, I expect a 0, right, as a remainder. So now, I can rewrite my fx. Based on my long division, fx is now equals to x minus 3, 2x squared plus 7x plus 3, right? This is fx. So when you see this quadratic portion, it should come to your mind that you should try and factorize it. Okay, even if you don't try and factorize it, fine, no, it's okay. Here I have rewritten the function in terms of factors. Am I answering the question? Is this the final answer? No. No. What do they want? They want to solve, right? Solving means they want values of x for which the equation is correct, for which the expression over there is equal to 0. Now this is my fx, which is the same over here. Now they are giving me an equation. They say that this is equal to 0, which means that this fx is equal to 0. Since something multiplied by something times something equals to 0, doesn't that mean that x minus 3 equals to 0 or 2x squared plus 7x plus 3 equals to 0? Right? So from here we get x equals to 3, and this is our Emaths. You can solve it using factorization, which in this case it works to get 2x plus 1 and x plus 3, or you can do your quadratic formula. Only then you get the 3 answers. Okay, many students stop at this step. I don't know why. You're supposed to solve. Give me the values of x. Don't stop there. Another mistake that I saw. And look whether you made a mistake. You write. You manage to divide properly. So you say fx equals to x minus 3, 2x plus 1, x plus 3. Okay, then you didn't have all this. And then you come to this step. What do you think of this presentation? Why? Everybody look at the screen. It's a common mistake. fx, you manage to factorize it. Then you tell me that x equals to 3, negative half, and negative 3. How does that make sense? Why? Why should x be equals to 3, negative half, and negative 3? Yes, the reason that it is equal is because it is equal to 0. If you just factorize without regard to the question, they said it is equal to 0. How can you expect to get the values of x? Remember, what you have done over there with fx is just to factorize. You need to show me the equation over here to get a 1 mark. Now looking back at this question again, is it tough? Okay, not tough, right? Quite basic. Yes. Every mark, 1.5 minutes. Okay, question 4. Express this in partial fractions. Surprise. What is the surprise? Give away mark, 1 mark. All I need to do is to write in the form a over x plus 1 plus bx plus c over x squared plus 4, because x squared plus 4 cannot be factorized. So now you tell me, what is the common mistake? No, this is the common mistake. Give away mark, right? 1 mark. It was even done during the revision. So, expand it out. Substitute values of x. We always want to find x values such that it is very convenient for us. In this case, I want to make all these be equal to 0. So I substitute x equals to negative 1. And I managed to find the value of a. Okay? Now the next one. What else is convenient? When x equals to 0, it is convenient because b is going to disappear. But many people didn't select this. A doesn't disappear. You've already found a. Okay? Many did not select x equals to 0. So you ended up with 2 equations that you needed to solve, which is not a problem if you do it properly. So if we chose x equals to 0, we have c equals to 7. And finally, choose any other value of x you like that is convenient. In this case, I prefer 1. Okay, substitute x equals to 1, and I get the value of b. So look, here we've got 1 mark given for you to rewrite the fraction into 2 parts. 1 mark each for the unknowns, a, c, and b. Final mark is to just put all these a, b, and c back into your partial fraction to get the answer. Yes? Sorry? ECF, error carried forward. Roots of equation, alpha and beta. The moment I see a's and b's in your working, I'll be wondering, what's a? What's a and what's b? then I will minus you 1 mark. Because you don't want to write alpha and beta, right? The question stated the roots are alpha and beta. They didn't say it is A and B. You chose to come up with some unknowns yourself. I don't know what they are. I minus 1 mark. Next, sum and product of roots. Very straightforward. 1 mark. I think there's only one student who didn't manage to get this mark. Careless or I don't know. Now find the roots of the equation. Sorry, find a quadratic equation whose roots are alpha square plus 2 beta square plus 2. So they want a new equation. These are my sum of new roots. Sum of new roots. Alpha square plus beta square plus 4. And we see that alpha square plus beta square is very familiar to us. We recall that alpha square plus beta square is actually the same as alpha plus beta square minus 2 alpha beta. Put them all inside here, plus 4. Substitute accordingly. Alpha plus beta is 2 inside here. Alpha beta is 3 over 2. Inside here you get 5. 2 marks for this. How generous. Sum of roots. Sum of new roots. Next, product of new roots. Product of new roots, simply expand. Remember, our goal is to rewrite everything in terms of sum and product of the old roots. So we've got expansion, we get alpha beta square, 2 alpha square, 2 beta square, and a 4. And we see that, hey, this is very easy lah. We simply square the sum of roots. Then over here we've got 2 alpha square plus 2 beta square, and we realize that this is the same as 2 times of alpha square plus beta square, right? And alpha square plus beta square, didn't we find it earlier on? We said that this was equals to 2 alpha plus beta square minus 2 alpha beta. Then just do all your substitution to get 33 over 4. That is our product of new roots. Once I have the product of new roots, that's where some of you got complacent. They wrote down the equation, new equation, equals to x squared plus sum of new roots times x plus product of new roots. Okay, so this is what I have. Tell me the mistake over here. Which one is a minus? Yeah, it should be a minus over here. So a lot of wasted marks. There is another problem with this over here. Is this an equation? Is this an equation? No, this is not an equation. This is just an expression. How can an expression have roots? It must be an equation. What is the equation supposed to be? Equals to 0. Only when it is equal to 0, then this will be true. We've seen how we can derive sum of roots, product of roots from an equation, from a quadratic equation. Only when it is of the form ax squared plus bx plus c equals to 0. And this is our answer mark. I also accept 4x squared minus 20x plus 33 equals to 0. They are equivalent equations. Oh, and that's all. Now looking back at this, I give you 3 minutes. Look through your paper. You think about it. Do you think you can get full marks for this paper? If you can do it again. If you get to do it again. Look at all the questions again. Think through your mind. What is your approach?